Hello everyone, in this video we'll be learning about polygons, their angles, sides and the measure of all the angles inside the polygon and the angles outside the polygon. So first of all, let's look into the definition of polygons. You know that polygons means any closed curve, right? Curve means something which should be made of line segments and it should be closed. Then it is called to be a polygon. There, as you can see here, there are some examples of polygons. Each of the polygon is made up of line segment and they are closed. You can have polygons which is not made of line segments and still it is closed, like a circle, right? So here we are going to focus more on those polygons which are made up of line segments and they are closed. Okay. The first most important definition and the most important property of a polygon is diagonal. Diagonal is a line segment which connects two non-consecutive. Consecutive means the one which lies one after the other. Means the two things which are next to each other. They are called as consecutive. So here the line, so two endpoints, 2 points which are connected together is by a line segment, right? So any two line segments which are lying next to each other, we are not considering them. Instead, the two end points or two vertex points which are not near to each other but they are opposite to each other. And when such two vertex points are connected, then the line segment that is formed is called as diagonal. Let's draw the diagonal for this shape, which is a square or a rhombus. So let's consider the vertices or those vertex points which are not consecutive, means this and this, these two are next to each other and they already been connected by a side. Similarly, this vertex point is connected to this, so they are again connected. So can we say this vertex point and this vertex point, they are opposite and they are non-consecutive? So if I join them, this is the first diagonal. Similarly, I can have one more diagonal, that is this, right? Next, if I take the next shape, okay. So if I want to draw the diagonal, I have to look at the non-consecutive, like this and this. So I can join it, right? It's a diagonal. Similarly, I can join this. Okay. What about this one? This will join, but it's not going to join to any vertex point. It's going to join the any point on the opposite side. So this is not a diagonal. Diagonal has to connect two vertex points of the polygon and these vertex points should be non-consecutive. Clear? Now, any polygon, the ones which we are looking into, will have sides. Sides means the ones which are connecting two vertex points, correct? And it has internal angles. So we are going to talk about that. Clear? So first we already looked into what is a diagonal. Now we'll first look into what is a regular polygon. A regular polygon is a shape or a polygon in which all the sides and all the angles are of equal measure. What is a regular polygon? A polygon in which all the sides and angles are of equal measure. So the shapes that we are going to look into right now are all regular polygons. So the special name for a regular polygon, which is having three sides, means it's normally called as a triangle, but the special name for a regular triangle is equilateral, right? Similarly, a four-sided shape, normally a four-sided polygon is called as a quadrilateral. Okay, but if all the sides are equal and all the angles are equal for the quadrilateral, then we call it as a square. So regular quadrilateral is a square. So let's look into the different properties of these polygons. So first of all, triangle. Tri means three. So this polygon has three sides and three angles. If all the three sides and three angles are equal, then we call it as equilateral triangle, and the sides are represented by n is equals to 3. Next is a quadrilateral. Quadri means 4, right? Quadrilateral. Quadri means 4. So regular quadrilateral is a square and n is representing the number of sides, which is equals to 4. The next one is pentagon. Penta means 5. So number of sides is 5. Okay, tri means 3, quadra means 4, penta means 5. Next shape is hexagon. Hexa means 6, six-sided shape. Next is heptagon. Hepta means 7 sides. Octagon. Octa means 8 sides. Similarly, nonagon. Nona means 9 sides, and decagon sides means 10. The thing that you have to look into is all these polygons, whether it is a pentagon, hexagon, or decagon, the sides are number of sides, all of them are of equal measurement, and all the angles are equal. So I give you this, I already mentioned the special name for the regular triangle as equilateral triangle. Similarly, regular quadrilateral as equilateral, sorry, as square. Whereas for the other shapes, it's regular pentagon, regular hexagon, regular heptagon, regular nonagon, regular decagon. Okay. So again, the number of sides and the name of the polygon. Three-sided polygon, triangle. Four-sided polygon, quadrilateral. Five-sided polygon, pentagon. Penta means 5. Six-sided polygon, hexagon. Hexa means 6. Seven-sided is heptagon, which is 7. Octagon, which is 8 because octa means 8. Nonagon means 9 and decagon is 10. Deca means 10. Clear? Now, polygon can be of two types. One is convex polygon. What does this mean? Convex polygon means that all the diagonals will lie inside the polygons and each angle of the polygon is less than 180. When I say each angle, I mean the angle inside the polygons. They add up to be, they are always less than 180, not more than 180. Okay. So here one rule is the diagonal of the polygon should lie inside the polygon itself. So yes, it's lying inside the polygon. Let's check this one. Here also the diagonals are lying inside the polygon. So how to check whether a given polygon is a convex polygon? Try to draw the diagonals. If the diagonals lie inside, then it is a convex polygon. There can be a case where the diagonals are not lying inside the polygon. Then in that situation, they are called as concave polygon. Like if you look at this, it's inside, it's inside. This is also inside, but there is a polygon which I can draw outside. Can you see? Like here. These are opposite vertices and they are connecting. So they are lying outside. Okay. So the polygons in which the diagonals lie outside the polygon is called as concave polygon. And the second property is that one or more than one angle will be more than 180-degree measure. Right? If you look at this angle, it's more than 180. It's a reflex, right? Similarly, here, this angle is more than 180-degree. So concave polygon means the diagonals, one or more than one diagonals lie outside the polygon and angles will measure more than 180. Concave polygon is this. Convex polygon, the diagonals will lie inside and the measure of the angles will be less than 180. Clear? Now, what is the relationship of the interior angles of a polygon? So interior angles means those angles which lie inside the polygon. So the rule says that the number of sides of the polygon, if considered as n, then the sum of all the interiors, if you are adding up all the interior angles of the polygon, then the measure can be found out as n minus 2 multiplied by 180. So let's start finding the total sum of interior angles of each polygon that we just saw. So triangle. Triangle has how many sides? 3 sides. Which are the interior angles? 1, 2 and 3. Right? So it is n minus 2 multiplied by 180, which is equal to 3 minus 2 into 180, which is going to be simply 180 because 1 into 180. Right? So the sum of all the interior angles of a triangle is 180. Next, let's go for quadrilateral. N is what? 4. So let's say this is the formula. 4 minus 2 into 180, which is equal to 2 into 180, which is 360. Okay, let's go for the next, pentagon and hexagon. Pentagon has how many sides? 5 sides. So 5 minus 2 multiplied by 180, which is 3 into 180, which is equal to, yes, 540. Next, hexagon, 6 minus 2 into 180, which is 4 multiplied by 180, which is equals to a 720. So let's see for heptagon and octagon, 7 minus 2 into 180, which is 5 times 180, which is a 900, right? Next, it's, yes, 8 minus 2 multiplied by 180, which is 6 times 180, which is 1080. Similarly, for nonagon and decagon, 9 minus 2 multiplied by 180, which is equal to, yes, 7 multiplied by 180, which is 1260. Sorry. And the last is 10 minus 2 multiplied by 180, which is, yes, 8 multiplied by 180. 1440. So this formula helps us to find out the measurement of all the interior angles. If they are added up, what is the total addition of all the interior angles of the polygon? It's n minus 2 into 180. So for a triangle, it's 180. It's called as sum of interior angles. Sum of interior angles of triangle is 180. Sum of interior angles of a quadrilateral is 360. Sum of interior angles of a pentagon is 540. Sum of interior angles of a hexagon is 720. Sum of all the interior angles for a hexagon is 900. Sum of all the interior angles of an octagon is 1080. And sum of all the interior angles of a nonagon is 1260. And sum of all the interior angles of a decagon is 1440. Similarly, if the total measurement of the addition of all the interior angles is given, okay, and they're telling us to find the find the measure of one angle. If you have to find the measure of only one angle of the polygon, then how to find? So measure of an interior angle is n minus 2 into 180 divided by n. So suppose we have triangle. So triangle is 3 minus 2 into 180 divided by 3, which is, yes, 180 divided by 3, which will give us a 60 degree. So this helps us to find the measure of one angle or each angle measurement of the regular polygon. So all the three angles of this triangle is 60, 60, 60. So it's a equilateral triangle. Similarly, for the next shape, it's a quadrilateral. So it's four-sided, right? So 4 minus 2 multiplied by 180 divided by 4, which is equal to what? 2 times 180 divided by 4, which is 360 divided by 4. That gives me a 90. And we know that all the measurement of the square are 90, right? And square is a regular polygon, right? So finding the measure of each interior angle of a regular polygon, the formula is n minus 2 into 180 divided by n, right? Similarly, if you want to find for pentagon, it's 5 minus 2 multiplied by 180 divided by 5, right? Which will be 3 into 180 divided by 5, which I'm leaving for you to solve. And the next shape is your hexagon. So hexagon is 6 minus 2 multiplied by 180 divided by 6, which is 4 times 180 divided by 6. Again, I'm leaving it for you to solve, right? Next, sum of measure of all the exterior angle of any polygon is going to be 360. Means this shape has 1, 2, 3, 4, 5. So if I add up all the 5 exterior angle, it's going to be 180. Similarly, this one is having 1, 2, 3, 4, 5, 6, 7, 8. So if I add all the 8 angles of this polygon, it will be equals to 360. So sum of all the exterior angle of any polygon is 360. So exterior angle of a decagon, if I add, it's 360. Exterior angle of a pentagon, if I'm adding all the exterior angle, it's going to be 360. So exterior angle is the angle which lies outside the polygon. And then when you add them up, it's 360. Hope it's clear. Thank you.